Okay, this one, arc sine, this is the same thing as inverse sine. So whichever way you want to write this, you need to understand though that arc sine is the same thing as inverse sine. And then you should also know that this is just another way of saying, well, if sine equals 1/2, then what is the angle? And that's what you're trying to find. So basically, if I'm looking at the unit circle, 1/2 is a common value for sine. So that would my unit circle out. When does sine equal 1/2? That's going to happen in two places. Sine is 1/2 here and here. So the answer to this is kind of tricky. If I'm asking for just arc sine of this, I have potentially two answers. But when it comes to sine, you're only going to be giving just the one answer, the one in the first quadrant. So the answer to this angle is going to be pi/6. Keeping in mind that even though I did all that work, really the one answer that you have is arc sine of 1/2 is equal to pi/6. Similar with cosine, inverse of cosine, what is that going to be? Going back to the unit circle, cosine is 0 in two places, here and down here, but I'm going to pick the one, the smaller the angles here, so 90 degrees or pi/2. This one they're kind of embedded here. So sine of pi/3, that's one you should know. Pi/3 up here, sine of that, square root of 3/2. So basically I'm going to simplify this, or replace it with square root of 3/2. So then I have arc sine square root of 3/2. And if you notice, this is asking when does sine equal square root of 3/2. So then I go back to here, and that's exactly where I was already looking. So the answer is just going to be what I started with, pi/3. And technically there's another answer over here, 2 pi/3, but I'm going to be picking the smaller the angles, pi/3. So this is pi/3. Which brings up the idea that what you started with is going to be what you finished with if it's talking about arc sine of sine. Because another way to write this would be that you're taking the inverse of sine. And so what you end up doing with this problem is that the sine, the inverse sine and the sine are undoing each other, so you're ending up with just pi/3. The next one, cosine, arc cosine, very similar situation, that cosine and arc cosine undo each other, so we might think that the answer is 1/2. So let's go about this a little bit more step by step. If I'm just looking at arc cosine, that's asking inverse sine or inverse cosine of 1/2. Looking at the unit circle, cosine is 1/2 here and here, but I'm going to pick the easier angle, basically pi/3. So this is going to equal pi/3. And then what I end up doing is I replace this, so then it would be cosine of pi/3. And then I would go back to this, go to pi/3, take the cosine of that, and I get 1/2, which is exactly what I had started with. So another example, or cosine and inverse cosine are canceling each other out because they're inverses. Down here gets a little bit different. Inverse cosine of 4/5. Why this becomes different is because this is not a common value on the unit circle. Meaning if I pull up the unit circle, nowhere am I going to find 4/5 as one of the common values. So that's not going to be helpful here. What I'm going to end up doing is drawing a reference angle, or reference triangle, where I kind of just choose one angle to be the one I'm looking at. And because I'm looking at this, and I'm looking at cosine, I know that cosine is adjacent over hypotenuse. And because I know that cosine is 4/5, because this one's asking, when does cosine of an angle equal 4/5? That means that the adjacent is going to be 4. Adjacent right here. And then the hypotenuse is going to be 5. Hypotenuse right there. So you could use the Pythagorean theorem, or if you've done enough studying, you'll know that this is just a 3, 4, 5 triangle. So now that I know every side of my triangle, I can find any cosine, sine, all of that stuff, all based on just this triangle. So now that I have this triangle set up, I'm interested in the tangent of this angle, and the tangent of that angle is simply just going to be the SOHCAHTOA opposite over adjacent. So that's going to end up being opposite, which is 3, adjacent, which is 4. So the answer to that is 3/4. So similar problem on the next, where I have an inverse tangent of something, 5/12, but that's not a common value. So I'm going to set up triangle, 5, tangent, I know is opposite over adjacent. So that means that's going to be 5/12, opposite side being 5, adjacent side being 12. And then what I can do is find the missing side using the Pythagorean theorem. So I'm going to say that the missing side x is going to be 5 squared plus 12 squared, which is 25 plus 144, which is 169. So that means x is 13. Take the square root. So my triangle is 5, 12, 13. Also another common triangle if you want to memorize that one. So now take the sine of all of this. Sine of theta would give me, let's see, sine is SOHCAHTOA opposite over hypotenuse, which would be 5/13. So the answer is 5/13.